Hello everyone. Today we're diving into some exciting topics that are shaping the future of technology. I recently watched two fascinating video titled Future of Semiconductors, Silicon Carbide and Gallium Nitride as next-gen semiconductors, and Silicon Carbide, a power electronic revolution. So this video these videos really got me thinking about the potential impact of this new semiconductor materials on various industry. So in today's video, I'm going to reflect on what I learned and explore how this advancement could affect computers, electric vehicles, automation, and even our future as computer engineers. So let's get right into it. So for the first question, how can the new semiconductor affect the development of more sophisticated computers? So silicon carbide and gallium nitride are materials that go beyond the limitation of traditional silicon, which has been backbone of our computing system for decades. These wide bandgap semiconductors are able to operate at much higher voltage, frequency, and temperature than silicon. What this means for computers is that we're looking at a future where processor can run faster, handle more data, and stay cooler, all while using less energy. So, for instance, silicon carbide can manage heat and electrical fields far better than silicon. This opens the door for designing CPUs and GPUs that are not just more powerful but also more efficient. Think about how our current computers struggle with thermal throttling. When they overheat with SiC based chip, we could push our hardware further without worrying about the overheating, which way more sophisticated AI, machine learning application, and even quantum computing advancement. And speaking of efficiency, gallium nitride could be a game changer in creating ultra-fast transistors. Imagine computers with significantly reduced latency and also enhanced data processing speed. So, as computer engineers, this this is particularly exciting because we will be able to innovate on new architecture that harness these capabilities, allowing us to push the boundaries of what's possible in computing technology. So that's why. And for the second question, what is the impact of the new technology to EVs and automation? So when it comes to electric vehicles or EVs, silicon carbide is truly a game changer. So in the video, it was highlighted that the Tesla adopted SiC in their Model 3 inverters. This this move helped them to reduce the size of their they call this inverters by half while significantly boosting efficiency. So why is this important? Because in EVs, efficiency directly what do you call this? Directly translate to longer range and faster charging times. The adoption of silicon allows electric vehicles to operate at higher voltage and higher temperature, which means less energy is lost as heat. So not only we can expect more efficient EVs, but they also be cheaper to produce in the long run, making electric cars more accessible to a broad market. But this doesn't stop at electric vehicles. This same technology has a massive potential in automation and industrial application. Factories that rely on heavy machinery can benefit from silicon-based power electronics that are more efficient and can handle higher temperature, reducing downtime due to overheating. So this could be revolutionize industry by enabling faster, more efficient automation system that can run all day or run 24/7 without the risk of overheating. And for the third question, let's go to the third question. So, what is the advantage of the new semiconductor as compared to traditional semiconductors? So, let's talk about the specific advantage here. Traditional silicon semiconductors have a relative narrow band gap, which limits their efficiency, especially in high power and high temperature environments. Silicon carbide, on the other hand, has much wider band gap which allow it to handle higher voltage and temperatures. This wider band gap also reduces energy loss, making silicon device more efficient. For example, um, silicon-based device max out at around 175 Celsius, while silicon carbide can go up to 300 Celsius or even beyond with the right packaging. This means that the system using silicon can run hotter and more efficiently without need the bulking cooling solution. And in application like EVs, where weight is critical factor, reducing the need for extensive cooling system can result in lighter and more efficient vehicles. Gallium gallium nitride also shines in areas where high-speed switching is required. Um, it's perfect for creating smaller, faster, and more energy-efficient power supplies. That's why you see GaN tech being adopted in everything from phone charger to satellite communication. And for the last question, so what is the future of computer engineers in relation to the new semiconductor technology? So as computer engineers, the rise of silicon carbide and gallium nitride is incredibly promising because this technology will shape the future of our passion or our profession in multiple ways. So first, there will be a growth in demand for expertise in designing systems that utilize silicon and GaN semiconductors, whether it's optimizing algorithm to leverage the speed of GaN transistor or designing thermal management solution for silicon-based systems. There will be countless new challenge to solve. But moreover, there are the integration of the semiconductors into power electronics, computing, and automation means we'll need to think how design everything from microprocessor to electric vehicles, powertrains. It's not just improving existing design, it's about creating entirely new categories of products. As these materials become more widespread, computer engineers will need to innovate more or new architecture that fully exploit their potential. And let's not forget about sustainability. With the world moving towards greener technology, the efficiency gains from the semiconductors are directly aligned with reducing carbon footprints. As engineers, we have responsibility to develop technology that are not only cutting edge but also sustainable. By embracing the SAC and GAN, we can contribute to build a more energy efficient future. So, to wrap this all up, these new semiconductors, silicons, carbide, and gallium nitride are not just incremental improvement over silicon. They represent a paradigm shift in how we approach technology, from the device we carry in our pockets to the cars we drive, and even the factory that produce our goods. As computer engineers, we're at the forefront of this transformation, and it's an incredibly exciting time to be part of this field. So, to close this video, I hope this reflection gave you some insight into why this advancement or significant. If you enjoy this video, don't forget to like and subscribe. So thanks for watching and I'll see you on the next video. So thank you.